I found in many applications I've worked on that decisions tend to be made in non-data driven manners. Let me give you an example. A significant part of Citybike's budget, Citybike in New York City, goes towards rebalancing. And the way it used to work was that those rebalancing decisions were mostly made by dispatchers based on their intuition about the system. Now, they had great intuition about the system, but intuition is not data. So an early project of mine with Citybike was about developing data-driven tools that would help these dispatchers in their decision-making. More broadly speaking, we see decisions being made, operational decisions, all the time in the world, where perhaps a data-driven approach might lead to better decision-making, might lead to decision-making that is also more easily explained. In many cases, that is currently not happening. There's certainly a trend towards changing that. There's certainly a trend towards more and more decisions being made using data. Decisions like inventory decisions in supply chain management. A lot of these decisions are based on maybe very old intuitions, are based maybe on this is how we did it last year, and they are not based on actual quantitative science. So on the one hand, one goal of my research is really to bring quantitative science to more such decision making. On the other hand, one does also need to recognize there's a question of how high stakes is this decision. If the algorithmic solution is going to cost us $1 million to implement, and the financial impact of this decision on an annual level is $20,000, maybe it's not worth implementing an algorithmic decision. But by and large, we find that in many situations, certainly in supply chain management, inventory management, we're not talking about $25,000 impact, we're talking about very high costs that can be reduced significantly through quantitative insights.